Hi everyone, I'm AG, and until now we already saw unique elements combination, but what happens if we extend this idea having repetitions? By example, in this 4-element set we can combine quantities, and these two right here are the same combination, cause they have exactly the same quantities, but this one not the same. How to tell how many will be? Well, to get this number we use a special n over k case, and the process will be pretty the same. So applying the formula we found that will be 286 different combinations with 4 elements in a 10-element set. Now to understand what the arrangements are, let's consider these 6 objects set right here. Among the 720 permutations, there is one group that doesn't contain items in its original position, like Secret Santa.
It is time to get your presents, wrap them, and place them under the tree, like so. First present, Oscar.
Shower radio, neat.
Pam.
Thank you very much, Santa, whoever you are. It's awesome.
Jim.
Oh, cool.
He obviously forgot to get me something.
Yep, that's exactly what happened.
Ryan.
No.
Whoa, video iPod. Wasn't there a $20 limit on the gift? This is $400.
You don't know that.
Yeah, you left the price tag on.
I did?
Yeah.
What? Oh, shoot. Michael.
Oh, hey, for me, what is in here? Oh, come on.
I knitted it for you.
Okay.
So Phyllis is basically saying, hey, Michael, I know you did a lot to help the office this year.
To make this game have sense, nobody can receive its own gift. So how many distribution options will be? Well, just divide the number of permutations by E, obtaining all the derangements. The pigeonhole principle. If 10 pigeons are contained in 9 pigeonholes group, by common sense, one of them contains more than one pigeon. The k-factor will be related to both pigeons and its holes. Let's see how we can take advantage of this idea to solve complicated situations. Let's suppose you start to fill this basket with random fruits from this set and must ensure have 5 same class fruits. It is possible to get only 5 same class fruits, but the probabilities of getting these randomly are very low. Now consider to choose 10 fruits and have 5 of the same class. It's possible, but again the chances are low. We can test with, let's say, 20 fruits. Let's try this random selection with a simple script. On your preferred browser, press F12 and open Developer Console. Those messages are not related to this subject. For now, just ignore them. Then copy the first part of the script, paste it into the console and press enter. The device has chosen 7 papayas, 5 apples, 4 pineapples and 4 bananas randomly, and the basket is filled according to the condition. Take out random numbers without explanation is not efficient at all. So instead of try with 150 or 20 selections, what scientists usually do is apply the pigeonhole principle as follows. The fruits can be seen as pigeons. The k-factor will be every class as pigeonhole, and the 5 fruits of the same class are another piece in the puzzle. With this method, we found that 17 random fruits are enough to match the condition. Copy the second part of the script and paste it again into the console to verify the same procedure, this time with 17. The following discussion is closely related to combinations as well. Remember what is a one-to function. It's a relation where all the range elements are linked to some domain element. How to tell how many combinations from set A to set B will be? Well, having m as the number of elements in the domain and n as the number of elements in the range, this number k is obtained throughout this formula. By example, we want to distribute the 7 fruits among the 4 girls. Every girl must receive at least 1 fruit. If not, she will be jealous. So how many options will be? To solve the problem, we use this expression that is a summation from 1 to the number of girls. First, replace each formula element with the data. Second, solve the inner operations. These combinations must be solved apart from these powers. Then multiplying the results inside the square brackets. We have a series of terms to solve. We found 8,400 different options to distribute the fruits. Now, you probably may be wondering to yourself what happens if B have more elements than A. Well, in that case, that will not be a surjective nor a one-to function. Using the previous method, find the number of possible one-to functions from A to B. Remember that m is the number of elements in the domain set and n the number in the range. After replacing the terms of the formula, we solve these n over k case combinations. Along with the powers, we found that can exist as much as 36 different one-to functions between A and B. Remember what is a partition. Cannot contain duplicates, must contain all elements. Well, an ordered partition is any custom arrangement. In this case, we must arrange the fruits into 3 baskets in a 3-2-2 format. How many options would be? To solve this discussion, we use the n over k case until no elements left. First, we have a 7 combination on 3, then left 4 combination on 2, and last 2 combination on 2. Finally, we apply the product rule. 210 different options to distribute the set in this format. Now, if you pay attention as always, I'm sure you are going to approve the following test. Let's go. From a 5 fruit menu, you want to order a 8 fruit basket. How many options you have? Before we start to solve this situation, let's discuss about it. What the clerk will ask you. Which fruits you want among the 8? So what case do you think can be applied to solve this? It will make any difference to have a fruit in front or behind, like in the car plate example? In these situations, you always must ask if the order is relevant. In this case, we don't care about the order, we just want the fruits, right? So the 2 first cases are beyond this problem. This is a combination with repetitions, and to solve it, we use a special n or k case. Let's introduce the data in the formula to obtain that will be 495 different combinations with 5 fruits set in an 8 fruit basket. Second question, you must find the minimum number of persons in a party to ensure that 4 of them were born in the same month. Could be 12 persons, like the 12 months. What do you think about it? After learn how to apply the pigeonhole principle, you will start to see everybody as a pigeon.
What chicken?
Who said there was a chicken?
Yeah, we didn't see no chicken.
Hey, could have been anybody crossing that road. Yeah, it didn't have to be no chicken.
Like it could have been pesto here.
Yeah, it could have been... Hey, wait a minute. Are you saying I'm a chicken?
I didn't say that. All I said was it could have been you.
I could have been a chicken. Is that it? Is that what you're saying?
I didn't mean nothing.
What am I? Some kind of plump domestic fowl here to amuse you?
Nah, I just said that it could have been you.
That's it! I'll give you a chicken! Here's your chicken! Come on, you want a chicken? I'll give you a chicken!
A pigeonhole principle situation is always to get the k factor. N is the number of pigeonholes. In this case, there are 12 months. The pigeons in the hole are k plus 1, so k equals to 4 minus 1. Among 37 random persons, at least 4 were born in the same month.
Okay, kids, let's do some business. Remember, no unauthorized personnel behind the counter. And most of all, smile, 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 or nuts are free.
Whoa, free nuts!
Kevin, he meant for the customers.
What?
Welcome to It's a Nutty, Nutty, Nutty World.
Let's suppose a customer wants an order with 9 different nuts. Within these groups, could be like this or that. How many options you have? This is an ordered partition and we use an special n over k case. First we have a 9 combination on 3, then left 6 combination on 2. We repeat the process until all options have been used. 7,650 different options to give this order is not.
Okay, hold on a second. There.
Wow, you did it! You sold a bag of nuts!
So happy you were here to share it with me.
Hi, welcome to Nutty World. Hi there, welcome to Nutty World. We're just crunching your lunch and sending your nuts.
Can I get 2 pounds, please?
Sure thing, ma'am. Hey, Daria, which one's runs again?
A customer wants 2 pounds any nut type. If each package weighs 45 grams, among all the nut classes, how many options you have? This is a combination on 20 packages of 45 grams. Among 9 different nut classes, we use a special n over k case. Millions of possible combinations. Better you decide quick.
These, right here. The ones with the sign that says almonds on them. That's the same word on the sign over there with the picture of the almond on it.
Oh, yeah, right. Thanks. So where did you point again?
I'd like my nuts, please.
Hang on.
By the way, if you want to see more advanced exercises about this unit, a link in the video description will be available. Thank you very much for watching our video and see you on Unit 6.